Like example problem 4, example problem 5 is a continuity of flow problem. And so right off the bat, we know that the continuity of flow equation is A1 squared V1 equals A2 squared V2. So we're going to have a big pipe and we're going to have a small pipe. In this situation, we're talking about an IV drip. And so this would be the big pipe and this would be the small pipe. So the saline solution is flowing from the big pipe into the small pipe. And both pipes are going to have an area and they're going to have a velocity. So A1 and A2, also there's going to be a V1 and a V2, just like the equation says. So the problem reads, a patient is receiving a saline solution through IV drip. The saline is passing from a larger 1.5 centimeter squared tube. Now it's in centimeters squared, but you still see that meter squared there. So that is going to be the area for the first pipe. So 1.5 centimeters squared. At a velocity of 2.445 meters per second, into a smaller 1 centimeter squared tube. So again, that's an area that's going to be for the small tube. So 1 centimeter squared to be delivered into the patient. What is the velocity of the saline solution entering the smaller tube? So we're looking for velocity here. Just right off the bat, doing a unit check, you can see that A1 and A2 are not in their correct units. We have to convert from centimeters squared to meters squared, and we have a conversion factor for that already given to us. So starting with A1 equals 1.5 centimeters squared, and we're converting to meters squared. There's a direct conversion factor for that, so it says that 1 centimeter squared equals 0.0001 meters squared. Centimeters squared cancels and we're left with meters squared. Don't forget to carry any of these 3 zeros. Sometimes that happens and then the answer is wrong, so just be very thorough when you're checking your problem here. So 1.5 times 0.0001 equals 1.5 times 10 to the minus 4th meters squared. Now we're going to go ahead and convert our A2, which was 1 centimeter squared. Draw the multiplication symbol, draw the division bar. Centimeter squared goes to the bottom to cancel, and meter squared goes to the top. And so the conversion factor does not change. There's still 1 centimeter squared and 0.0001 meters squared. Centimeter squared cancels and we're left in meter squared. So 1 times anything is going to be itself. So this is going to equal 0.0001 meters squared. Now we're ready to put these things or prepare these things to go into the continuity of flow equation. Never forget to square your areas, because if you do, the answer will be wrong. So 1.5 times 10 to the minus 4th squared and 0.0001 squared, and you can put them into your calculator just like that. So open parentheses, 1.5 second e to the minus 4 close parentheses squared is 2.25 times 10 to the minus 8th meters squared. And then 0.0001 squared equals 1.0 times 10 to the minus 8th meters squared. Now we're ready to put these numbers into the continuity of flow equation. So A1 squared we calculated to be 2.25 times 10 to the minus 8th meters squared. The velocity, remember we don't do anything with those, we just bring them straight down into the equation. So 2.445 meters per second equals A2, which we calculated to be 1.0 times 10 to the minus 8th meters squared. And V2 is what we're looking for. You can use an X or you can use the V2. It doesn't matter to me, whichever one you like better. So we need to isolate x and get it by itself on the right side of the equation. So draw a division bar and divide by 1.0 times 10 to the minus 8 meters squared, and that cancels. And bring it on over. 1.0 times 10 to the minus 8 meters squared. And now you're ready to put this into the calculator. So 2.25 second e to the minus 8 times 2.445 divided by 1.0 second e to the minus 8 gives us a final velocity, so V2, of 5.50 meters per second. Let me know if you have any questions about example problem 5.